Hello geometry students. This is the video for example 3 for geometry topic 3 lesson 5. Now we're going to identify rotational symmetry. For what angles of rotation does the figure map onto itself? An equilateral triangle. Rotate the figure in the tool to the right by dragging the slider. Okay, so I'm going to drag the slider. It's going to show us some angles, I thought, except I was not able to grab it. There we go. And we're just seeing, does it end up back on top of itself? Yeah, whoops, we were right about there, 120. Keep going. Right there at 240. And then that one doesn't count, 360 doesn't count. So it looks like it happened at 120 and 240. A rotation of 120 degrees creates an identical image with B at the top. Rotational 240 creates an identical image with C at the top. Okay, that means it has point symmetry. If there's a point that you can rotate and end up, not 360, 360 doesn't count. For what angles of rotation does the figure map onto itself for a parallelogram? All right, same thing. I'm going to rotate it and see what angle measures this works for. I know I probably got to go all the way across to here. At 180, and then it won't happen again until I get all the way back. So only 180. The type of symmetry for which there is a rotation of 180 degrees that maps a figure onto itself is called point symmetry. Oh, I think I misspoke on the previous problem. A parallelogram has 180 degrees rotational symmetry or point symmetry. So it has to be 180 degrees to be point symmetry. The previous problem had 120 and 240, so that one did not have point symmetry. It needs to have 180 degrees. Let's see what the next thing is. It's a try it, so if you want to try this on your own, go ahead. Click pause. What are the rotational symmetries for the figure, and does it have point symmetry? Okay, so if I stick a point right in the center and then rotate it, how many degrees can I rotate it and it will be back on itself? I think, because it's like the x-axis, y-axis, I can just rotate it 90 degrees and then 180, and since it's 180, that means yes, it has point symmetry. And then I can go to 270 before I go to 360. So I think it's 90, 180, and 270. 90, 180, and 270, and since it has 180, it has point symmetry. All right. Here's another try it. Click pause if you want to try it on your own, and then come back. What are the rotational symmetries for the figure? Does it have point symmetry? Okay, so if I stick a point in the center and I start to rotate it, the long end comes up. This is like the rectangle, I think. The long end comes up. It's not going to be lined up until I get all the way around to 180. And then it doesn't happen again. Whoops, sorry. It doesn't happen again until I get all the way around to 360. So I think only 180 is the only one. And since it is 180, that means it has, yes, it has point symmetry. There it is. And believe it or not, that's it for example 3. Here's the problems you can do: 13, 14, 16, and 29, 21, and 22. That's it for this video. Have a great day.